advanced spanning tree features. And here I'm going to talk about 3 in particular that I noticed that a lot of my students and CCIE candidates are struggling a great deal with. So these features are going to be Portfast, BPDU guard, and BPDU filter. Now, these 3 features, as I said, is something that a lot of students are struggling a lot with. And one of the contributing factor for the struggle about these features is somewhat imprecise documentation from Cisco about what these features do, and then added to that is the interpretation of various people around the internet about that. So if you are going on all sorts of different blogs and social media sites to read about these 3 features, beware about what you read, because most of those articles that you will find are in one or many ways very, very wrong about that, including, unfortunately, a particular article written by yours truly. So I'm now giving you a warning. Be careful about what you read about these 3 features, because the information out there on the internet may not be as correct as you hope. Now, when you are in the CCIE lab, the grading proctors don't care what it says on the internet or in the documentation about these features. They care about what these features actually do. So this is what we are going to explore today, and with a little bit of luck I will be able to prove how these features actually behave and what is their purpose and how they actually work. So let's attack the first one, the Portfast. Now, the Portfast, the usual understanding of this feature is that the interface that has Portfast enabled on it will skip listening and learning phases of the spanning tree. Now, the important thing to know about this is only when interface comes up. So this does not apply if interface was, for example, in the blocking state and has Portfast enabled on it. In that case, the interface will actually have to go through listening and learning phases, and I will explain why. Now, to explore this feature a little bit, we need to understand that there are 2 ways of configuring this feature. One is global, and the other way of configuring this feature would be per interface. Now, in both cases, these features are conditional on incoming BPDUs. What I mean by that is that if we enable Portfast on a particular port, and on that port we actually receive a BPDU, any sort of BPDU, the Portfast on that port will actually be disabled. Now, when you take a look at the interface that is configured as such, it is going to appear as if the Portfast is enabled on that port, because what you are going to be seeing is the actual configuration of the interface. To illustrate that, I'm going to start, and by the way, the ping we started a long time ago is still ongoing. So what I'm going to do now, I'm on Cat 3 at the moment, and we have this interface Fast Ethernet 24, which is now configured as the trunk. So what I'm going to do is, on both of my switches, in fact, I'm going to undo the changes that I did before. So I'm just going to say default interface Fast Ethernet 23 and default interface Fast Ethernet 24. And I'm just going to say that interface Fast Ethernet 23 is going to be shut down, and I'm going to make interface Fast Ethernet 24 switch port mode access, switch port access VLAN 10. So I'm just going to make these switches configured as such, because I really don't want trunks right now, because I want to explore the behavior just of the Portfast as it behaves on a single interface that is actually an access port. So now if I take a look at the configuration of the interface, this is how you would configure a normal access port. So let's go to Fast Ethernet 24. I am going to shut this interface down, and I'm going to say spanning tree Portfast. So when you enable spanning tree Portfast, you are getting this warning message here that says that Portfast should be only enabled on ports connected to single host, etc., etc. So it kind of gives you warning that you might be creating loops. Now, as you will hopefully see real soon, this is a misplaced warning. There is actually no need for this warning to be in place. So if I take a look at show interface FastInet24, I see here that Portfast is enabled on it. So let's do the exact same configuration on FastInet23. So here is FastInet23, and I'm going to say spanning tree Portfast. And let me just do that on both switches at once. So this goes in and this goes in. So now I have two interfaces. Actually, there is maybe a more efficient way of doing that. So this is the configuration that I'm going to have on Cat4 and on Cat3. So if I do show spanning tree, what I'm going to be seeing now is that in our VLAN 10, which is the only active VLAN right now because these are access ports, FastInet23 on Cat3 is route forwarding and FastInet24 is alternate blocking. Now, we are using RSTP, so maybe these interfaces came up because of the RSTP faster. Let's change that as well, even though it's unrelated, but I want to show you the default behavior. So spanning tree mode PVST. So I'm going to change the spanning tree mode. And let me just shut these interfaces down on Cat3. So I'm going to do no shutdown, and then when interfaces come up, I'm going to do show spanning tree. So there we go, the interfaces are up. Doing show spanning tree, and take a look. FastInet23 is immediately in forwarding, and FastInet24 is in blocking state. Now, you might remember from one of the previous examples is if I was to shut down FastInet24 now, because we are running the traditional spanning tree, the per VLAN spanning tree plus, what will happen is that FastInet23 would go from forwarding to listening and then learning phases. But now the Portfast is enabled on that port. So what will happen if I actually go to FastInet23 and I shut it down? If I do show spanning tree, this is what happens. The port is actually going into the listening phase and it will go into the learning. Now, if I take a look at the interface, as I said, I see the Portfast enabled. But this is the administrative state of the Portfast, not the actual operational state of the Portfast. If I run the command show spanning tree interface FastInet24 Portfast, this will tell me what is the actual operational Portfast state on the port. So Portfast on this port was actually disabled. Why was it disabled? Well, if you remember our topology that we are dealing here with, we have switch 1 that is connected to switch 2. Actually, it was switch 3 and switch 4, but doesn't matter. And this one here was configured to be the root, which means that root is actually sending BPDUs. Now, the fact that I have actually configured Portfast on these ports was effective when these ports were taken out of shutdown. So, for very brief moment in time, these both ports were forwarding, but then the BPDUs were received, and then these ports actually lost their Portfast status. So they are no longer Portfast ports. Why? Because the incoming BPDU removed that operational Portfast state. This is what I mean that they are conditional on incoming BPDUs. But let me show you that brief moment in time when both of these interfaces are actually forwarding the traffic. So what I'm going to do here, I'm going to say interface range FastInet23 to 24. I'm going to shut them down and I'm going to say do show spanning tree VLAN 10. So what I want to do is I want to have this command in the command history because I will be running it very fast a couple of times. So I'm going to say no shutdown and immediately going to start running this command. And there we go. Let me scroll back up. So when the interfaces initially came up, I can see here that both interfaces are actually designated and forwarding. So the Portfast worked. The interface changed state from down to up and the Portfast takes effect. Now, if you take a look at here, next time I ran it, it was still the same status. And here, at this point, So we can see here that there were a couple of log messages. There was a brief loop. The MAC addresses flapped from one interface to another. So for a brief period of time there, yes, we do have a problem. But relatively quickly, in worst case scenario, 2 seconds, if this is the BPDU hello time, for up to 2 seconds we are going to have that problem. But then take a look at what happened. The port 24 immediately changed state to blocking, and this one remains forwarding because it was supposed to be forwarding to begin with. And then the state continues normally. Now, this is why you get that warning about the Portfast, that it can create temporary loops in your network. But my opinion of it is that it's rather misplaced because you're going to get a very, very temporary loop. Now, even temporary loops could be a problem in your network, but in most environments, this problem would have not been noticed by production traffic. Now, another point that I want to illustrate is on Cat4, Portfast was also configured. And this is yet another misconception that I see with many CCIE candidates, is that when you enable Portfast on the port, you are actually not sending BPDUs out of this port. That is not true. The BPDUs are actually going to be sent out of this port, even if the port is Portfast. So the only thing that Portfast actually does is when the port initially comes up, it will skip listening and learning phases. But all other operations when it comes to spanning tree are still there. The BPDUs will be sent, and the BPDUs, if received, they will be processed, except that the incoming BPDU will actually reset the Portfast state. The port that receives the BPDU will no longer be a Portfast port. Now, going back to the configuration, there are two ways of configuring it. The global is when in the global configuration mode, we say spanning tree, Portfast, default. Now, this, let me just do this a little bit better. So spanning tree, Portfast, default. This will enable Portfast on all operational access ports. So all ports that are in operational access mode will be enabled for Portfast. This includes ports that have been statically configured for access with switch port mode access, or dynamic ports that have actually failed to negotiate the trunk. So if you had dynamic ports and they fail to negotiate the trunk, when you configure this command, you are actually going to be enabling Portfast on those. Now, when you're configuring per interface Portfast, the command is interface X and then spanning tree Portfast. Now, there is an optional trunk keyword that you can configure there. If you do not configure it, Portfast will be active on operational access port. Now, if you configured trunk, will include trunks as well. Now, what I mean by this is, let's say that you had a port that was configured for Portfast. So you had interface fastnet 01 and you had spanning tree Portfast trunk configured. And you say here switch port mode access. Now, this port will be Portfast because you configured spanning tree Portfast. But this trunk keyword here says, even if this port is a trunk, be Portfast on it. What you cannot do is tell this interface, be Portfast only if you are trunk, but if you are not trunk, don't be Portfast. This is impossible to do. So the only thing that you can actually do is you can tell the port to be Portfast even if you are trunk. So if we had a configuration that looked something like interface fastnet 02 and we had spanning tree Portfast configured and we had switch port trunk encapsulation .1q and switch port mode trunk. So let's say here that this will be port fast, but this one here will not be port fast, because spanning tree port fast here does not include trunks. So if you want this interface fastnet 02, let's do the third example here. If I had interface fastnet 03 and I had spanning tree port fast trunk, and I had switch port trunk encapsulation .1q and switch port mode trunk, this will actually be port fast because I am including the trunk keyword here, and the interface is trunk or an access port. So this here is not a valid configuration if you want to have the port fast, but these two are actually both acceptable solutions to make these interfaces port fast. Now, I should point out that port fast is a Cisco proprietary feature that Cisco implemented to work around a specific problem originally noticed with Windows 98. Now, Windows 98, and very, very relevant for 2013, I'll give you that, but when Windows 98 was booting, during the boot process, it would send the DHCP request a couple of times during the boot, but then it would never ever stop that, resend those DHCP requests if there were no replies received. Now, this was a problem if the spanning tree on the port was going through the listening and learning phases, because this port would be actually dropping those DHCP requests coming from a PC, so Cisco needed to find a way to work around this limitation in Windows 98. So they came up with this port fast feature. But port fast feature was actually received so well by the networking community that it actually got standardized with the rapid spanning tree, where it's called the edge port functionality. Now, the edge port functionality in the rapid spanning tree brings a couple more behavioral changes. One thing is that when we have a port that is declared to be an edge port, any change on that port does not cause the switch to send a topology change notification BPDU, which would cause other switches to actually lower the aging timers on their MAC address tables, because it is considered to be just that, an edge port. Now, for Cisco to maintain the backwards compatibility with all the configurations that were implemented, when you are running rapid spanning tree, when you are actually typing out the command spanning tree port fast, what you are actually doing is not configuring Cisco specific port fast feature, you are actually configuring a standardized edge port feature. So Cisco kept the same command line, but it's two very related, almost identical features, except that one is standardized behavior, the other one is Cisco specific when you are running non-rapid spanning tree. So this is port fast. Now, one of the most important things from this that I would like you to take is that there is this concept of, where did I put it? That there is this concept here of operational port fast state. Now, this is very different from what is actually configured on the interface. This is how the interface actually behaves right now. And this idea of an operational port fast state is very, very important for one reason only, that there are other features on Cisco switches that actually depend on the operational port fast state of the port, not on the administrative configured state on the port, but instead on the actual operational port fast state. Now, one of those features is BPDU guard. BPDU guard is a relatively easy feature to explain. Any received BPDU will cause the port to be error disabled. So this is what BPDU guard does. When you enable BPDU guard on a certain port, basically any incoming BPDU will cause this port to go into the error disabled state. Just like with port fast, there are two ways of actually configuring this feature. One is global, and the other one is per interface. Let me first explain per interface configuration. It's very, very simple. You're going to say interface, X, spanning tree, BPDU guard, enable. Now, what this feature does is unconditionally enables BPDU guard on that interface. Now, what I mean by unconditional is this feature, when enabled on per interface basis, is not dependent on the Portfast state. Basically, on that interface, if we receive BPDU, that's it. Bam! The port will go error disabled. Let me show you that. So, sorry, I'm going to go to Cat3 here, and I'm going to say interface, fastnet23, spanning tree, BPDU guard, enable, done. So what's going to happen now? Immediately when the port was received, this port here became error disabled, right? So there was no delay, there was nothing. And if I do show interface, fastnet23, what I'm going to see here is that the port is actually error disabled. I hope this makes sense. Let me remove this feature from the interface, and to recover from the error disabled state, by default I actually need to shut the interface down and bring it out of shutdown. So there it is, the interface is back up, and there it is, it says connected, and fastnet24 is also connected, so I'm all good there. Now let's take a look at the globally configured BPDU guard. The configuration for that is in the global configuration mode, spanning tree, Portfast, BPDU guard, default. Now, what this do, or what this does, is that enables BPDU guard on all operational Portfast ports. Now, again, emphasis on operational Portfast ports. Now, this doesn't matter, are they trunks, are they access ports, how they were Portfast. Were they Portfast as the result of the global configuration using spanning tree Portfast default, or were they Portfast ports because they were enabled per interface? No matter how the interface actually became Portfast, if it is Portfast and you have this command configured, the interface will actually have guard enabled on it. So let me show you one more thing. So here I have my Cat3 and Cat4. So this is the interface, fastnet 023 and fastnet 24. And as we can see, I have Portfast enabled on both of them. So I'm going to go in the global configuration mode, and I'm going to say spanning tree, Portfast, BPDU guard, default. So when I enter this command, I should be seeing both of those interfaces going into error disable. But I'm not actually seeing that. I'm not seeing that because none of those interfaces are in operational Portfast state. They actually are disabled for Portfast. So if I enable this command right now on ports 23 and 24, it will have absolutely no effect. But let's say that I go to interface fast internet 23 and I shut it down. Now, when I shut it down, the operational Portfast state is cleared. And when I do no shutdown, when the port initially comes up, it will be actually operational Portfast. Now, when this port comes up, it will receive a BPDU from the other side, but because at this point in time, it was actually operational Portfast, the incoming BPDU will actually reset the state on this port. So there we go. We can, sorry, not reset the state, but it will actually error disable the port. So take a look. Guard here did have effect. Now, fastnet 24 is still unaffected by it because it is in operationally, the Portfast is operationally disabled on that port. So if I do show interface fastnet 23, I will see that now the BPDU guard kicked in. And this is what I mean by this is actually dependent on the operational Portfast port. It says enables BPDU guard on all operational Portfast ports. But again, a thing to note, that FastNet 23 became Portfast not as the result of the global configuration. It became Portfast as the result of per port configuration. So it doesn't matter how this port became Portfast. The global configuration did take effect on it because it was an operational Portfast port. And yet again, FastNet 24 is at the moment unaffected by that configuration because we have configured it after the Portfast was actually turned off on that port, the operational Portfast. The next thing that I'm going to talk about, if you thought that BPDU guard is a little bit unknown or maybe a little bit complicated, what comes up next is downright bizarre. So the next thing that I'm going to talk about is BPDU filter. Now, BPDU filter is very, very unfortunate thing. It's an unfortunate thing because there are actually two very unrelated features in iOS that carry the same name. Now, one feature is when you enable BPDU filter as the result of the global configuration. And the other one is when you enable it per port. Now, I'm going to talk about per port one because that one is much, much easier to explain and much, much easier to actually understand. The configuration there is on the interface. So interface X, we're going to say spanning tree, BPDU filter, enable. Now, what this command does is unconditionally filters all incoming and all outgoing BPDUs before they are seen by any other feature. This is an equivalent of turning off spanning tree on that port. So this port will not send a single BPDU out, and all incoming BPDUs will be dropped before they are seen by any other feature. And by this any other feature, what I actually mean is Portfast or guard. So if I configure BPDU filter on the port, no BPDUs will be sent or received on that port. So let me demonstrate that in action. So I'm going to go to my Cat3 and Cat4 here, and I'll start with Cat3. On interface range, FastNet 23 to 24, I'm going to shut them down. Now, remember that on this port, what I have configured is Portfast per port, and I also have guard configured globally. Okay, so when this port comes up, if I receive the BPDU on this port, the guard will kick in, just like it did in the previous example. But now on the ports, I'm going to enable the BPDU filter. So this is the configuration of my port 23 and my port 24. So I'm going to do no shutdown here, and my port should come up and stay up. Well, I do get Mac flap notification. Take a look at this. FastNet 23 and 24 are both designated forwarding. This bridge is the root. So Cat3 now thinks it's the root. Now, we have Cat4 configured as the root, but Cat3 cannot see this because we have effectively turned off the spanning tree between them. Now, you remember that warning message that you get when you type in spanning tree Portfast on the port, and you get that warning message that says, oh, by the way, this can create loops? That's a completely misplaced warning. Here, when I typed spanning tree BPDU filter on the interface, which actually is the dangerous one, I'm getting zero warning. But if I take a look at one thing, so bear with me for 1 second here. So what I'm going to do is I'm just going to change load interval to 30, just to see statistics not on a 5-minute basis, but 30-second basis. So I'm going to say show interface fasting at 23. Take a look at the traffic on my network. Now, this interface has been up for about, what, 1 minute maybe, and we are already having 12 megabits per second. And now if I take a look at the run, we are now at 29 megabits. If I take a look at the configuration now, we are at 31 megs, etc. And by the way, there is no traffic on my network. What is looping now are spanning tree BPDU frames, the CDP frames, maybe an ARP coming from Cat3 or Cat4, because I do have those SVIs. There is no traffic on my network, so to speak. There is no production traffic, and I have a bridging loop in place. Now, if I leave this for 5 or 10 minutes, I'm going to hit 100 megs and my network will start experiencing serious issues. So this is the situation that spanning tree is designed to prevent, but now I have effectively turned it off. So on Cat 3, there is no spanning tree. Now, on Cat 4, if I do show spanning tree here in VLAN 10, I have the exact same situation. Fasting at 23 and 24, they're both designated forwarding because Cat 4 thinks it's the root. So I have a completely cut off spanning tree between these two. So this is what spanning tree BPDU filter does on the interface. It effectively turns off the spanning tree operations on that interface. Not all of them, because if I remove the port fast from the interface, so if I say fasting at 23 here, and let me do the same thing on fasting at 23 and 24. So I'm going to shut them down now, and I'm going to remove the port fast. Okay, so this is now the configuration on the two of my interfaces. So port fast is now gone from the picture, and if I do no shutdown, show spanning tree VLAN 10, take a look at this. Now the ports are going to go through listening phase and the learning phase, but this will not change the fact that this bridge will remain the root, that these two ports will eventually move into the forwarding state. So we can see that if they go into the learning, they will go to forwarding. So I'm just delaying the formation of the loop now. So port fast is not the culprit here. It is the BPDU filter that is actually causing the problem. And there we go. Now we have converged to the exact same situation that we had before with the port fast. And we can see that the BPDU filter as configured on the interface is not actually conditional on the port fast state of the interface. It's a completely unconditional thing. Now, let's take a look at what BPDU filter does when it's configured globally. So the command line for configuring the global BPDU filter is spanning tree portfast BPDU filter enable. I'm sorry, not enable, default. Apologies about that. Now, when you configure this on the global interface, outgoing, actually, let me start with the incoming. Incoming BPDUs, actually, let's start over. This is conditional. It enables, I'm going to call it global BPDU filter on all operational portfast ports. Just like with the BPDU guard in the previous example, it doesn't matter how the port became portfast. If it's portfast, no matter what, this feature will actually be enabled on it. But I'm calling it the global BPDU filter here because, as you will see, the behavior is somewhat different than this one here. So it enables global BPDU filter on all operational portfast ports. What it does is outgoing, or actually incoming, BPDUs are not filtered. Which means that incoming BPDUs will not be blocked by this feature. Most, but not all, outgoing BPDUs are filtered. Let me demonstrate this feature. So to do this, I'm going to go back to my terminal, and just to check on the state here, yeah, we are now at 22 megs. So let me stop the loop. So I'm just going to shut one of these interfaces down, because it is actually slowing down my switches a little bit. They are fairly busy. You can see that this is maybe not a lot of bandwidth, but 43,000 packets is considerable amount of bandwidth. So what I'm going to focus on is port number 3. Now, port number 3 is the port that you might remember from one of the previous examples that was configured for monitoring. So I'm going to remove that stuff. And all I want to do is have port Fastnet 03 to be up and running, because this is what is connected to my Wireshark capture. So let me go to my Wireshark here, and what I'm going to do is I'm going to actually not going to restart the capture, but I do have the filter that is capturing only the spanning tree frames. So going back to my terminal, I'm going to configure interface Fastnet 03. Let me shut it down. I'm going to say that it is interface switch port mode access switch port access VLAN 10, and I'm going to say that it is spanning tree. Actually, not going to do that. I'm going to configure it as a global Portfast. So spanning tree Portfast default. So all operational access ports will be now Portfast by default. And I'm going to say spanning tree Portfast BPDU filter default. So now all operational access ports will have the global BPDU filter enabled by default. And I'm going to go to interface Fastnet 3, and I'm going to shut it down. So going back to my Wireshark, I'm going to restart the capture here, which will do really nothing. Okay, let me do that. Which will do really nothing because I don't have any traffic going in there. So going back to my terminal, I'm going to say no shutdown, and let's go back to my Wireshark. So here is the BPDU, and as you will see, and as I said, this is truly bizarre behavior. So there we are. This is the 5, 6, 7, 8, 9, 10, 11, and that's it. I'm not going to receive any more BPDUs now. So when the port came up, 11 BPDUs were sent out of this interface. After these 11 are sent out, no more BPDUs will be sent. Now, what's the catch here? Well, the catch here is that when configured globally, the BPDU filter is going to filter most of the outgoing BPDUs after it has determined that there is no switch connected on the other side. Now, what is Cisco doing here? It looks weird, but it actually isn't that bad idea. Now, imagine that you had 2 switches, just like we have. So switch 1, and let's say switch 2 here. And that we had multiple links connecting them. And for whatever reason, these were all access ports. And they were all enabled globally for Portfast. And you had the global BPDU filter enabled. Now, if you connect this as it is, what we are going to end up having is the loop just like the one we had before. But when we are using the global Portfast, what's actually going to happen is this switch here, if these are ports that are Portfast as they are and are enabled for global BPDU filter, is actually going to send a BPDU here. Now, when this port here receives this BPDU, it will reset the Portfast state on it, and with it reset the configured global filter, which means that a similar thing might happen in return, that the BPDU from this side is actually going to reset the state on our end, which means that we can converge our network in a loop-free environment. So Cisco is trying to kind of idiot-proof the network to prevent us from inadvertently creating the loops by using the global BPDU filter, because BPDU filter is such a dangerous thing to have. Now, when you configure it per interface, as you've seen, it's unconditional. In that case, Cisco says, okay, you better know what you're doing because this turns off spanning tree. In fact, this is what I should say when you enter that command, but I don't. They warn you about the Portfast, which is not even close to being dangerous in comparison to the BPDU filter. So this is what the global BPDU filter does, and this is what per port BPDU filter does. Now, the reason why I'm telling you this in such a great detail is that you could go into the lab and the task in the lab could say, configure all interfaces facing routers as access ports in appropriate VLANs and make sure that they immediately come up when you configure them, and make sure that you are not sending any BPDUs out of these ports. So you might be thinking, okay, I have to configure 10 ports, they're all access ports, so I'm just going to make them globally portfast and don't send any BPDUs. Yeah, I'm just going to enable BPDU filter globally to prevent BPDUs from being sent. How does that work? Because look, we are going to be sending 11 BPDUs out of each and every one of these ports. You have just failed that task. So what you need to do here is you can configure all of them as access ports, because this is what the task says. You can configure them as the global portfast, that's perfectly legit, but then you have to go on every single interface and enable BPDU filter on those interfaces, because if you don't do that, you will be sending some BPDUs, right? Or an alternate task could be configure all interfaces facing routers as access ports, make sure that you are putting them in the appropriate VLANs, make sure that they start forwarding traffic immediately when the interfaces come up, and send enough BPDUs to detect if the switch is connected on the other side. Now, what they are telling you there is to actually use the global the global BPDU filter, because with the global BPDU filter, you will be actually sending some BPDUs to detect the switch on the other side. And if you detect the switch, you are going to continue operating spanning tree normally and not creating the loop in your network. This is very, very important to understand. One thing that I want to explain, and this is the order of operations when you have Portfast, when you have BPDU guard, and BPDU filter configured on the port at the same time. So let's say that this here is the port and that we have an incoming BPDU on that port. Oops, what am I doing here? So BPDU. Okay, so if we have, let's say that we are dealing with BPDU filter local, that means per port. So the first feature that sits on this port will be the BPDU filter. The next feature that sits right behind the BPDU filter will be the BPDU guard, and then we have Portfast here, which means that the incoming BPDU will actually hit the filter, and this frame will be dropped before the guard is encountered, which means that if you had a configuration like this, so interface X, spanning tree, BPDU filter, enable, and spanning tree, BPDU guard, enable, and spanning tree, Portfast, this here is completely meaningless, because you will never ever hit the guard in this case, because BPDU filter will get rid of this traffic before it is actually seen by the guard. Now imagine that there was no BPDU filter here, the guard will be hit before the BPDU filter, before the Portfast is actually encountered. But let's take a look at another example, and in this case here, let me just clone this page. So in this case here, let's say that we are dealing with a Portfast, with the BPDU filter that is configured not locally, but instead that it was actually configured as part of the global configuration. So this is going to be the global case. Now, in that case, the order of operation is slightly different. The first feature that we are going to encounter here is going to be the BPDU guard. Just below the BPDU guard is where we have the Portfast sitting, and the BPDU filter actually is the last feature that will be encountered. That means that the incoming BPDU here will first hit the guard if it's configured, and then it will reset the Portfast. But with the Portfast, because there is this relationship between these two, the filter will actually be gone from the interface as well, if it was configured as the global. So this is the order of operations if you have these multiple spanning tree features configured on the interface at the same time. So this is, again, yet another thing that is important to understand, because at least one of these combinations makes no sense. If you have this configured on your interfaces, it makes no sense, because the guard will never ever be active on this port, as we have seen in our example, I believe.